Okay, hello guys. So in this video we would like to discuss about equilibrium. So equilibrium, it has a symbol here. The symbol is something like this. So it's a two-way arrow. So typically in your normal reaction, like for example hydrochloric acid reacting with sodium hydroxide will form sodium chloride and water. So we will have just this arrow. It means that the reaction is going forward, or it will produce a certain product only in that direction. However, if the reaction has this symbol, it means that after reacting, there is a possibility that the products can also form the reactants back again. For example, ammonia added with hydrochloric acid can become ammonium chloride. But ammonium chloride can also dissociate or decompose back into the materials. So imagine that in this reaction it will form ammonium chloride, then after some time the ammonium chloride will also decompose, forming again reactant, then it goes again and so on. So equilibrium means that the rate of reverse and forward reaction is the same. Yeah, it's the same. In equilibrium, there will be no changes of concentration. For example, like in this part. So we can say that this is the reactant part or the material, while this thing is the product. Initially, we will have lots of material. However, as time goes by, the reactant will go down and down and down, reach a certain point, while the product, initially zero, will start to form until it reaches a certain point. So eventually there will be no more changes in concentration. It means that we already achieve equilibrium. Now equilibrium can be disturbed. So we have what is called the Chatelier Principle, or LCP. These are the factors that can cause disruption to equilibrium. So an equation that is already in equilibrium. For example, we have that reaction earlier, ammonium plus hydrochloric acid. So reversible can become ammonium chloride. There are some factors that are discussed in Le Chatelier Principle. So the first factor is concentration. So for example, imagine that this is the reactant, this is the product. If you increase the number of reactant, you add more materials, then logically the number of products will also be more, right? So if you increase reactant, then we will get more products. So the products will be produced more. Yeah. Maybe an analogy will help. For example, like I have a reaction of plastic and plastic bottle. Yeah. Plastic can become plastic bottle can also become plastic. So let's say that I am giving more plastic to the company. It means that the company can create more plastic bottle. So increasing one thing will make it go to that direction. Yeah. But imagine that I increase the number of plastic bottle. Yeah. So I give more plastic bottle. Then you say maybe like, okay, we have too many plastic bottle. So now let's turn it back to plastic so that we can have some materials. So what's the main takeaway here, guys? So increasing concentration will shift the reaction to the other direction. Meaning it will produce more the other things on the other side. Increasing reactant will have more products, while increasing more products will get you more reactants. So this is the first factor. So the second factor is actually pressure and volume, but they are very deeply correlated. So actually, if you increase the pressure, then the volume will be lower, right? Imagine like a balloon. So if you press a balloon with more pressure, then the volume of the balloon will become smaller. But imagine that if you let go of the balloon, then the volume will grow. So in this reaction, we have to evaluate the number of molecules. So on the left side, there are 2 molecules, right? And on the right side, only 1 molecule. So it means that on the left side, there are more molecules, while on the right side, less molecules. So if you decrease the volume, it will go to less molecule, favor. While if you increase the volume, so more molecules favored. Yeah. How can we decide the molecule? So actually we calculate all the molecules and their coefficients. So for example, we have something like this. Nitrogen plus 3 hydrogen, so becomes 2 ammonia. Yeah. So it means that on the left side here we have 1 and 3, so in total 4 molecules. While here we have 2 molecules only. So this part here we have more molecules, this part we have less molecules. So this is the correlation of pressure and volume to the equilibrium shift. Finally, we have temperature. For temperature, it needs to depend on the reaction, whether it's endothermic or exothermic. Yeah. Reactant becomes product. Also the same thing. Okay. For exothermic reaction typically releases heat. So originally the reactant is hot, and then the reactant is throwing heat away, so the product will be cold, right? This is exothermic. While for endothermic, initially the reactant is cold, but then it gains heat, so the product will be hot. If you increase the temperature, increasing temperature will favor the side that is hot. If you reduce the temperature, it will favor the cold side. So for example, if this reaction here, so nitrogen plus hydrogen becomes ammonia, let's say is exothermic, let's say. If we increase the temperature, it means that more nitrogen and more hydrogen will be produced. So the ammonia will be taken away and transformed back to nitrogen and hydrogen. But if in this reaction, which is an exothermic reaction, the temperature is decreased, then the more products will be formed, or more ammonia will be formed. So this is just an example. Okay? So one more factor is catalyst. So catalyst actually works by lowering activation energy, yeah, in a reaction. So this is the reactant, this is the product, and this is the minimum level of energy needs to be achieved. Yeah. If you have a catalyst, then the energy requirement will be much more lower, like this. Yeah. But catalyst will not change the product or reactant at all. Catalyst will just change the time required. So it will just make it faster to achieve equilibrium. Okay, so that's it about the Chatelier principle and some basic things about equilibrium and reversible reaction.